Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0172, indicates a fuel system too rich condition in the Honda HRV 2016 to 2022 models. A rich fuel system means that there is an excess of fuel in relation to the air entering the engine, which can lead to poor fuel economy, increased emissions, and potential engine damage if not addressed. This diagnostic code often arises due to issues with components like the mass airflow (MAF) sensor, the air-fuel (AF) sensor, fuel injectors, or possibly the engine control module (ECM) programming. It's crucial to accurately diagnose this issue to pinpoint the exact component malfunction causing this rich condition before proceeding to clear any codes or reset the powertrain control module (PCM). Diagnosing P0172 also involves understanding the roles of each component in the fuel management system. The DTC P0172 specifically refers to a situation where the fuel mixture in the engine is overly rich, meaning there is too much fuel being supplied compared to the amount of air. This imbalance typically involves several key components. The mass airflow (MAF) sensor measures the amount of air entering the engine and informs the engine control module (ECM) to adjust the fuel injectors accordingly. Meanwhile, the AF sensor, which measures the concentration of oxygen in the exhaust, plays a critical role in fine-tuning the air-fuel mixture. The injectors themselves deliver the fuel to the engine, and failures in any of these components can lead to a DTC P0172. The ECM is located within the engine compartment, and it processes signals from these sensors to achieve optimal combustion. Identifying the possible causes of DTC P0172 is crucial for effective troubleshooting. A faulty MAF sensor can incorrectly inform the ECM of the air entering the engine, which results in improper fuel delivery. Engine oil contamination can also lead to poor engine performance, affecting the PCV, positive crankcase ventilation system, which can disrupt the air-fuel ratio. Clogged fuel injectors may fail to deliver the correct amount of fuel, potentially leading to an overly rich condition. Additionally, weak fuel pressure impacts the injector operation, possibly resulting in excess fuel. Finally, a malfunctioning A/F sensor could mislead the ECM regarding the air-fuel mixture, contributing to the rich condition. When experiencing DTC P0172, a number of symptoms may arise. One of the primary indicators is a noticeable drop in fuel economy due to excessive fuel being used for combustion. Drivers may also detect a strong gasoline smell from the exhaust, indicating the fuel mixture is too rich. Engine misfires are another potential symptom, as an overly rich fuel mixture can disrupt the combustion process, leading to rough running. The check engine light will illuminate, prompting the need for code diagnostics, and overall engine performance can be significantly reduced due to this imbalance in the fuel system. The first troubleshooting step for DTC P0172 involves confirming the issue by starting the engine and allowing it to idle without any load. This means placing an automatic transmission in P or N and a manual transmission in neutral, to ensure no additional stress is placed on the engine during this test. Using the Honda Diagnostic System, HDS, check the air-fuel feedback, AFFB, which represents the short-turn fuel trim. A reading less than 0.79 indicates an issue that needs to be addressed. If the AFFB is low, this confirms there is a rich condition. You will proceed to the next troubleshooting step. If it's within parameters, then continue with the alternate verification method. The second step in troubleshooting DTC P0172 involves analyzing the onboard snapshot taken by the HDS when the AFFB was at its lowest. This snapshot enables diagnostic technicians to gather critical parameters such as engine speed, vehicle speed, relative throttle position, and accelerator pedal position. After recording these values, operational testing under conditions similar to those captured in the onboard snapshot is necessary. By securely driving the vehicle, check the real-time values for AFFB using the HDS again. A confirmation that AFFB remains low under these controlled conditions once again indicates the presence of a rich condition that needs further investigation. For the third troubleshooting step, start the engine once more and allow it to idle. At this point, gently pinch the positive crankcase ventilation (PCV) vacuum hose to observe how it affects the operation of the engine. This step helps diagnose whether the oil condition affects the air-fuel mixture. Using the HDS, check the parameters for AFFB while the hose is pinched. If the AFFB reading remains below 0.79, it suggests that the engine oil is contaminated and requires changing. If not, indicating the oil condition is acceptable, move forward to the next troubleshooting step to identify other possible issues. In this fourth troubleshooting step, the engine should be held at 3,000 RPM until the radiator fan activates. This step ensures adequate operating temperature, as the engine coolant temperature, ECT, sensor 1 must read above 158 degrees Fahrenheit, 70 degrees Celsius at this time. After confirming the proper conditions, the engine speed should be maintained at 2,500 RPM to monitor the MAF sensor values. The MAF sensor should read between 4.9 and 6.9 grams per second, G per second. If the readings are within this range, it indicates that the MAF sensor is functioning correctly. If the MAF sensor reading fails to meet this standard, further inspection of the air intake system is warranted to identify possible blockages or damages. In this fifth step, ensure the vehicle is turned off, lock mode, before proceeding to safely remove the mass airflow, MAF, and intake air temperature, IAT sensor. Inspect these sensors carefully for any physical debris, such as lint, bugs, or other foreign objects that could impede their performance. Any identifiable debris should be removed, and using a vacuum cleaner, clean out the air cleaner housing to ensure full airflow. After ensuring cleanliness of the MAF sensor and the air cleaner, recheck the connection of the sensors and reinstall them. If debris was present, replacement of the sensors may be necessary if they are damaged during inspection. The sixth step focuses on checking the fuel pressure while ensuring the AFFB reading is 0.79 or less. This measurement is vital in diagnosing potential fuel delivery issues. It is essential to validate that the fuel pressure falls within the acceptable range of 390 to 440 kPa, 3.98 to 4.49 kilograms per centimeter squared, 56.6 to 63.8 psi. If the fuel pressure is within this range, it suggests that the fuel delivery system is functioning properly. However, if the measurement falls outside this threshold, it indicates that there may be a malfunction within the fuel tank unit, necessitating its replacement for optimal engine function. In the seventh troubleshooting step, especially if a fuel-related issue is suspected, drain the fuel tank thoroughly and refill it with high-quality, known good fuel. This step is particularly crucial if there has been a recent instance of misfiring after refueling, as it may indicate bad fuel. Following the refueling, operate the vehicle under the same conditions previously recorded when the AFFB was low. During this operational test, check the AFFB readings again using the HDS. If the AFFB remains below the threshold of 0.79, it confirms that the problem does not lie within the quality of the fuel. The 8th step requires replacing the A-field sensor, sensor 1, with a new, known good sensor to assess its impact on the air-fuel mixture. This sensor is essential for monitoring the mixture's composition, sending critical feedback to the ECM for adjustments. After replacing the sensor, operate the vehicle under the same conditions where the A-field FB previously measured below 0.79. While driving, recheck the A-field FB readings with the HDS. If the reading is still low, then the A-field sensor cannot be the source of the problem. If the A-field FB reading adjusts favorably, it indicates that a faulty A-field sensor was indeed at fault, necessitating further assessments. In the final troubleshooting phase, if prior steps cleared all misconceptions, replace the fuel injectors with a set of known good injectors. Fuel injectors play a crucial role in accurately dispensing fuel into the combustion chamber. Therefore, their malfunctions can significantly impact the air-fuel ratio. Following the installation, operate the vehicle once more under the same conditions as previously noted when the AFFB value was low. Again, verify the AFFB readings through the HDS. If the reading remains low after the injector replacement, this would indicate that the issue may reside within the powertrain control module, PCM, necessitating substitution or reprogramming for resolution. After completing all requisite repairs and replacements associated with DTC P0172, it is crucial to confirm that all actions taken have resolved the issue. Start by verifying that all components involved have been correctly installed and functioning as intended. Following this, recheck the AFFB readings with the HDS to ensure they are now within an acceptable range. Lastly, when confident that the problem has been resolved, clear the DTC from the system and reset the PCM. It's vital to monitor the system in the following days to ensure no recurrence of DTC P0172 takes place, confirming that the rich condition has been permanently remedied. To prevent a recurrence of DTC P0172, implementing a solid preventive maintenance schedule is essential. This includes regular checks of the fuel system, air intake systems, and exhaust systems to ensure all components are clean and functional. Utilizing high-quality fuel can mitigate potential risks associated with fuel debris affecting sensors. Furthermore, consistently replacing air and fuel filters ensures that obstructions do not arise, which can lead to imbalances in the air-fuel mixture. Keeping the ignition system components well maintained and promptly addressing any minor issues before they escalate into larger problems can significantly lower the risks associated with DTC P0172. In conclusion, effective troubleshooting of DTC P0172 is vital to maintaining optimal engine performance in the Honda HRV 2016 to 2022 models. Each component linked to the fuel system, from the MAF sensor to the fuel injectors and AF sensor, plays a crucial role in ensuring the engine runs efficiently. Recognizing the symptoms of a rich fuel system can prompt timely intervention, while understanding the causes aids in pinpointing the exact location of the fault. Additionally, implementing a preventive maintenance plan is essential for minimizing the likelihood of future occurrences of this issue. Ultimately, early detection and efficiently addressing issues will help maintain your vehicle's performance and longevity. Please like and subscribe to the channel. See you next time.